In this lecture, we continue our discussion on artificial intelligence, and we will focus on machine learning and related algorithms. We're also going to talk about some mathematics behind it. All right, there will be 3 sections. First of all, we will have an introduction about some basic concept of machine learning. Then we're going to talk about some examples, some business applications. Before we talk about machine learning, let's consider how humans are learning. We have a picture here, and we all know it is a pear. But how did we learn this, that this image represents a pear? Think about this cute little baby. There are many different pictures here, including cartoons, drawings, photos. We will know all of them represent pear or pears. So how does the baby learn a pear is a pear in the very beginning? As people grow up, we gradually and naturally learn the characteristics of pears. Although there are many different colors, shapes, size, we can immediately recognize them. Even this picture has many pears in it. We still know they are pears and edible. But this simple process can be very difficult for computers or machines to learn what is pear. We need to figure out the explicit learning process for machines to recognize a pear. Before we talk about machine learning, let's also see how traditional programming works in the computer world. On the input side, we have 2 things, data and program. Data means raw data, including numbers, text, images, voice, many things. Can be big data. We also have the software programs, written codes, or instructions as a type of input. Based on the 2 types of inputs, the machine or computer calculates the output. The outputs are usually some meaningful result we need. For example, business decisions or projections or forecasts. Now let's see the machine learning process. Very different than the traditional programming, this picture shows how machine learning works. On the input side, we still have 2 things. We still have the similar raw data, such as numbers, text, images, voice, or whatever, big data. Instead of giving a software program or coded instructions, we now provide the desired output as an input. For example, we want a desired output of 3. These information were given to computer or machines, and we want the machine to deduct the process of procedures that converts the raw data to desired output of 3. In other words, the machine will figure out the steps or new program. You can see, this is a reversed process when compared to traditional programming. All right, let's go to the machine learning definition. In 1959, Arthur Samuel defined machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. Arthur doesn't know too much about chess, but he makes his machine to play chess by itself, train his machines. Finally, the machine plays better than him. There are 2 types of machine learning. In supervised learning, the training data include the desired output. We provide the data and tell the machine this is a pear. So the machine learns from a large amount of data about how to distinguish pairs. In unsupervised learning, training data does not include desired outputs. We provide the data but do not tell the machine these are pears. It can be apple, pear, or oranges. The machine will learn itself to distinguish pear from other fruits. Obviously, Unsupervised learning are more advanced AI technique. All right, we have some basic introduction, and then we can move on to some examples of machine learning. There are many different approaches in machine learning. We call them methods, algorithms. These include neural networks, support vector machine, naive Bayes, Bayesian network. As you can see, many of these approaches are statistical methods. This is very normal because we are dealing with input data, usually big data. Therefore, if you want to be an AI scientist, you must be good at numbers, formulas, equations, and most importantly, statistics. If you're not good at statistics, you'll have difficulties in learning artificial intelligence. But as business students, we don't need to bother too much with algorithms. You only need to learn how to use them and apply them in solving business problems. Neural networks are a hot topic in AI in recent years. Let's see how it works. The neuron here is the basic working unit of the brain, a specialized cell designed to transmit information to other nerve cells, muscles, or gland cells. Most neurons have a cell body, an axon, and dendrites. Neural network consists of numerous neurons connected together. In the world of AI, neural network technology simulates how human brain works. In computer, we need to represent problems into mathematical equations. Here we have this simple example to illustrate this. We say output y equal to input x times the weight w. The weight represents certain kind of mathematical manipulation. It can be multiply or divide. If we have the input of 2, output of 8, then w equals to 4. This gives the relationship between x and y. If we move things around, the original equation can be represented this way. The expressions are only in one side or on the right. The left side are defined as error term, which equals to the absolute value of the expression. The smaller the error term, the better the result, or the more precise the result. 0 is an ideal value, of course. Let's see how it works visually in graphs. We will plot the error terms in multiple iterations. In the beginning, let's try w equal to 0 and put this into the expression. We calculate this and we have -8. Taking the absolute value, the error term equals to 8. Plot it on the graph. So we have 0 here and 8 here. Second round or second iteration, let's try w equals to 0.8. Put it in. We have error term absolute value equal to 6.4. Plot it on the graph. It will be here. Third round, let's try w equal to 1.6. And then we have 4.8. And then plot it on the graph. The fourth round, similarly, we have the result of 3 and plot it here. Fifth iteration. Try w equals to 3 and the error term equals to 2. More iterations, plot the result. With more iterations, the error term becomes smaller. You can see the error term equals to 1, right? The line flows this way. But it's still not small enough, which means the answer is not precise enough. Keep trying. Results still not small enough. Keep on our mind that 0 is the ideal value. We need it to be very close to 0. Keep trying. 3.9 is getting smaller, but still not too close to 0. 0.2. Try it one more time. 3.99. Wow, error term equals to 0.02. 2 digits behind the decimal points. Close enough. Let's stop here. The computer learned that when W equal to 3.99, the error term tends to get 0, which means the results are very close to desired value. This is the machine learning process. We've just seen an extremely simple example with only one input, which means only one x. What about multiple inputs or multiple x, such as x1, x2, x3? Let's take a look of 2 x's. Of course, we still have one desired output, y. Since there are 2 inputs, x1 and x2, there will also be 2 weights, w1 and w2. The error term can still be represented like this, but w represents 2 values here. X also represented by 2 values. In reality, the expression will be calculated in matrix. Think about if you have 10 inputs, then you have 10 x's and 10 w's. Yes, it can be very complicated, and you'll know the importance of mastering matrix and linear algebra. Alright, similarly, we try multiple iterations to let error term to be close to 0. We try many rounds. For the last slide, the machine learned that when W1 equals to 0.99, W2 equals to 0.99, the error tends to be very close to 0, and it gets to an acceptable precise result. The equations is showed here. You can see how computer is learning. Actually, I know you guys are very smart to learn it from rule of thumbs. The real function is simply y equals to x1 plus x2, right? 3 equals to 1 plus 2, right? Remember, we are just using this simple example to illustrate how machine learns. As you can see from this simple example, computers do not learn as intuitively as you are. It uses mathematical expressions with trials and errors to learn. This is its limitation. Let's still use the pear as an example. This picture comes with many characteristics. The colors, the shapes, the size, the dots on this picture. All of these things are inputs and will become x1, x2, x3, and xn. The machine will figure out the mechanism to recognize in the hidden layer. There can be many temporary values in the middle, and we need to have multiple weights or w's to calculate the results. The weights also need to be updated in multiple iterations in the learning process. Now you know that the learning process is actually the calculation process. The machine calculates, or we say computes, the results. In this picture, we have output on the other end. Is a pair or not a pair? In other real-world problems, there can be numerous inputs, x1, x2, until xn. The hidden layer may include many layers and calculate many weights. As you can imagine, the machine learning process can be extremely complicated. Remember what we learned in the beginning of the course. We have better CPUs, memories, and large volume hard drives. All of these technologies help us to do better machine learning. Alright, we've learned the machine learning process and mechanisms. Let's see some applications. AI or machine learning can be applied in all areas of business. Whenever there are data, we can use machines to learn and predict the patterns. I know you guys are very creative and innovative, so the applications are unlimited. Some available applications can include finance, marketing, e-commerce, HR, and many other areas. You name it. Remember, in the last lecture, I provided a mortgage example. Now you can look back into the picture, see what's the input, what's the output, the middle hidden layers. Now you can have a better understanding what the computer are doing in that example. Some other examples, including Google Translate. It is also using machine learning to translate one language to other language. Amazon is also an AI company. The company uses it a lot in many different areas. Chatbots, always say virtual assistant. They're absolutely AI and machine learning applications here. AI can also be applied in HR. For example, this is actually my paper published several years ago. You can find it on my Google Scholar page. Machine learning can also be applied in scientific research. Drug development are using AI a lot. The previous president have recognized the importance of AI. For example, President Obama said, "My successor will govern a country being transformed by AI." This was in 2016. And you know what? President Trump signed a presidential executive order to promote AI in 2019. He wanted America to be the #1 in artificial intelligence. Alright, the president have told you AI is important. This is why I want you to explore a project in big data and AI. I hope you can learn more in this area.